Hello, in this video we are going to learn about permutations and combinations. Particularly, the first one will be permutations with repetition. Second, permutations without repetitions. Then I will teach about combinations, and finally permutations with repeated characters. So stay tuned until the end of the videos to have a complete understanding of the permutations and combinations. So let's start off with what is actually permutation. So in a permutation, order matters. So for instance, let's say we have A, B, C is actually different from B, C, A because order matters. However, for combination, order doesn't matter, which means that A, B, C is essentially same as B, C, A because they are in the same group of having A, B and C each. So let's try with the first example of what is permutation. Let's say we have the example of A, B, C, D, and we want to find out in how many ways that we can arrange two characters out of these four characters A, B, C, D. So we list AB, BA, AC, CA, AD, DA, BC, CB, CD, DC, BD, DB, and finally we have these 12 different arrangements. So if you want to use the permutation formula, which is NPR, we will have n factorial over n minus r factorial. So in this case, what is our n? We have 4 characters, so it's 4p. Now we want to arrange only 2 characters, so we have 2 here. So it's 4 factorial over 4 minus 2 factorial. 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1 over 2 factorial is 2 multiplied by 1. So we cancel. We will get 4 multiplied by 3, which is 12. So if you look at the listing methods that we just now did, we also have 12 different arrangements. Again, to remind you that the keyword for permutation is always arrange and order matters. Next, we will talk about combination. Let's say we have example A, B, C, D. In how many ways that we can group 3 characters? Group of 3 characters. For combination, order doesn't matter, and so ABC is the same as BAC, and is the same as CAB. So for combination, we always use the formula NCR equal to n factorial over n minus r factorial and r factorial. So in this case, let's say we want to choose 3 characters from the 4 characters. So our n is 4 and our r is 3. So we have 4 factorial over 4 minus 3 is 1. 1 factorial is 1. R is 3 factorial. So the answer is 4 multiplied with 3 factorial over 3 factorial, which is 4. So we only have 4 different combinations from this example. So let's try using the listing method. So we will have first ABC equal to BAC equal to CAB. This is the first combination. So we could also have another combination which is ABD, and we also can have another example, BCD. This is another type of combination. So first combination, second combination, third combination, and final combinations will be, so you can have a top. So all of them have B already, so finally is CAD. So by using the listing method, we can see that we can have 4 different combinations, which is also the answers that we shown here. Let's move on to some exercises to help you further in understanding the concept. So first exercise, in how many ways that the number from 1 to 3 can be arranged with repetition. So the keywords here is actually arrange. So when you see arrange, you know that this is a question of permutation. So to do this, first we write down 3 empty space. So for the first digits, you can think of how many numbers that can be filled in the first digits. So there are 1, 2, and 3. So there are 3 possible outcomes for the first digits. So you write down a 3 here. Then for the second digit, since you know that this is a with repetition, means that you can still write down the same digit. So there are also equal number of possibilities in the second digits, which is also 3. And for the third digit, you know that there are also 3 possible numbers that can be filled for the third digit. So it's also 3 possible ways. So you multiply together, you will get the answer. There are actually 27 ways to arrange the numbers 1, 2, 3 with repetitions. So to use the listing method, we can list down the possible outcomes. So start off with 1, 1, 1, since it can be repeat. 1, 1, 2, 1, 1, 3, 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 3, 1, 1, 3, 2, 1, 3, 3. So these are the possible arrangements that starts with 1. So we repeat for 2. 2, 1, 1, 2, 1, 2, 2, 1, 3, 2, 2, 1, 2, 2, 2, 2, 2, 3, 2, 3, 1, 2, 3, 2, 2, 3, 3. So you can notice that the first digit changes only compared to the first outcomes that we have here. So the next one will be 3, 3, 1, 1, 3, 1, 2, 3, 1, 3, 3, 2, 1, 3, 2, 2, 3, 2, 3, 3, 3, 1, 3, 3, 2, 3, 3, 3. So you count the total possible arrangements here. You can see that there are also 27 ways of doing this. Is you can use n to the power of r, where n is the number of digits. So 1, 2, 3, there are 3 type of different digits. R is the number of digits that we want to have. So here we want to have 3 digits number, so to the power of 3 here. So the outcome is 27. Let's try another example. In how many ways that the number from 1 to 3 can be arranged without repetition? So for these questions, first thing you must ask yourself, is it a permutations or combinations questions? So as we see that the keywords here is arrange, we know that this is a permutations questions. And secondly, since this is without repetitions, means that once the number is arranged, you cannot repeat to use that numbers again. So for this, let's say if we want to arrange for 3 numbers, So how many possible ways that we can actually fill out the first digit? 1, 2, and 3. So there are 3 possible outcomes. So after we fill out the first digit, how many different possible ways that we can actually fill out the second digits? There are actually 2 possible ways that we can fill out the second digits after we fill out the first digit. So after we fill out the first 2 digits, how many possible ways that we can actually fill out the last digit? There's only left with 1 number. So the total number of ways is actually 6. Alternatively, you can use the listing methods. For instance, let's say we use the listing methods here. We start with 1, 2, 3. Since it's without repetition, we cannot repeat the numbers. So 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So there are 6 possible ways that you can actually arrange 3 digits uniquely. So another way to do it is to use the formula that we discussed just now, NPR. So in this case, we have 3 digits. We want to arrange 3 digits as well. So 3p3 is 3 factorial over 3 minus 3 factorial. So to recall, the formula for permutation is n factorial over n minus r factorial. So 3 factorial over 3 minus 3 is 0 factorial. So to remind you that 0 factorial is actually equal to 1. So 3 factorial over 0 factorial is 3 multiplied by 2 multiplied by 1 is actually 6. So you get the same answer by using the formula as well. So let's move on to the next example. How many different group of 3 can be formed from 10 students? So you need to ask yourself whether order matters or not here. So as we can see that we are forming group of 3 people, so order doesn't matter here. When order doesn't matter here means that we are actually doing questions for combinations. So the keyword here is group and form. So that means that the order doesn't matter here. So to use the formula for combination, which is NCR, n factorial over n minus r factorial multiply with r factorial. So here our n is 10 students and our r is 3. We want to form group of 3. So 10 factorial over 10 minus 3 is 7 factorial over 3 factorial. So 10 factorial is 10 multiplied with 9 multiplied with 8 multiplied with 7 factorial over 7 factorial multiplied with 3 factorial is 3 multiplied with 2 multiplied with 1. So 7 factorial can be cancelled and 3 multiplied with 2 is 6. So we know that the numerator is 90 multiply with 8 over 6. So we have 15 multiplied by 8 is 120. So this is a question for combination. Let's try one more example. In how many ways that you can arrange three numbers from the number 0 to 9 without repetition? So this is a question of arrangements, means that order matters. So we are doing permutations questions. So we have 10 digits here, 0 to 9. So we want to write down first 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to pick three numbers and then arrange without repetitions. So we write down 3 empty space. So what is the possible numbers of outcomes for the first digits? So we actually have 10 digits here. So first is 10. So after filling out the first digits, how many possible digits that can be in the second digit? Remember that it is without repetitions. So after you fill out the first digits, the number of possible digits that can be filled for second digits is actually reduced by 1, so it's 9. And finally, after you pick your second digits for this arrangement, you will left with only 8 digits to be picked because you cannot repeat the number of digits. So you will get 720 possible arrangements. So to do this using the permutations formula, we can use NPR. So N is actually 10 here because we have 10 digits, and R is 3 numbers that we want to arrange. So 10P3. So we see that we have 10 factorial over n minus r factorial. So to recall, we have this formula, n factorial over n minus r factorial. So we will get 10 factorial over 7 factorial, and 10 factorial is 10 multiplied with 9 multiplied with 8 multiplied with 7 factorial. So you will actually get the same outcome, which is 720. So let's move on to one more very interesting example. So how about if we have repeated characters, how many ways that we can arrange? So as we always ask ourselves whether this is a permutations or combination questions by looking at the keywords here, arrange. So when we have arranged, we know that this is a questions of permutations. So let's start off with the first example, Alibaba. We see that we have 3 repeated characters here, 3 A's, and we have 2 B's. So in order to do this kind of questions, we calculate the number of characters here first. We see that we have 7 characters. So we write down 7 factorial over how many unique characters for A is 3. So we write down 3 factorial. And how many B characters we have in the words Alibaba is 2. So we write down 2 factorial. So the answer will be 7 multiplied with 6 multiplied with 5 multiplied with 4 multiplied with 3 multiplied with 2 over 3 factorial is 3 multiplied with 2. 2 factorial is 2 multiplied with 1. So as we can see, we cancel 3 multiplied with 2 with 6 and 2 with 2. So we will get 35 multiplied with 12. So 35 multiplied with 12 is 35 multiplied with 10 plus 35 multiplied with 2. We will get 350 plus 70, which is 420. Let's move on to the second example. Let's say we have 2. So we have 2t and 2o. And we have 5 characters here. So 5 factorial over 2 factorial and 2 factorial. So 5 factorial is 5 multiplied with 4 multiplied with 3 multiplied with 2. 2 factorial is 2 multiplied with 2. So we cancel 2 with 4, you will get 2. So 5 multiplied with 2 multiplied with 3, we will get 30. So I hope you have a better understanding of how to deal with repeated characters for permutations. And if you like my video and you want to learn more about statistics and also other mathematics topics, you can like and subscribe. Thank you.